Okay, hi everyone. What I'd like you to do is to get that huge piece of paper that I gave you. One side says y equals sine x, and then the other side says y equals cosine of x. Okay, so you have one that looks like this. It takes up the entire piece of paper. At the very top, you should have y equals cosine of theta or cosine of x. Regardless, we're going to graph this one right now together. Okay, all right. So reminder here, when we graph y equals cosine x, I'd like you to remember on the scrap paper what Mr. Logue did really nicely was he gave us the marks on the y-axis. This is radical 3 over 2. This is radical 2 over 2, of course. Here's 1/2 and here is 1. Okay, so we are looking at y equals cosine of x. Looking at the x-axis here, we are obviously in radians. So let's go ahead and input some values. This will be kind of a nice test to see if you remember anything about y equals cosine x. What's y equals cosine of x? If x is 0, what is the cosine of 0? Someone? Yes, it's 1. Here we go. How about the y equals the cosine of? Now here's pi over 2. Let's go over to pi over 4, okay? Because we're going to do the first time we see the graph of y equals cosine x, we're going to do this pretty methodically. X equals pi over 4. What is the cosine of pi over 4? It is radical 2 over 2, so I'm right here. Okay, I don't know why this is happening. Let's see. Okay, so I've got this, and I've got, sorry, a glitch. Y equals pi over 2 radians, or y equals 90 degrees. Cosine equals pi over 2 radians, or cosine equals 90 degrees. What is cos of 90? It is 0. All right, what is the cosine of pi, or 180? It is negative 1. Let's take the angle between pi over 2 and pi. This is 3 pi over 4. Okay, 3 pi over 4, what's the cosine of 3 pi over 4? Cos of 3 pi over 4 is negative radical 2 over 2. We're right here. Okay, and then I'm going to go to, let's see, cosine of pi is 4 pi over 4. Here's 5 pi over 4. 5 pi over 4, we are in quadrant what? Quadrant 3. Reference angle 45 degrees. Cosine is negative radical 2 over 2. Okay, cosine of 270 degrees is 0. And now I'm going to kind of pick it up. Cosine of 2 pi, or 360, is 1. And of course here is a 7 pi over 4. Cosine of 7 pi over 4 is radical 2 over 2. I'm going to go here and go negative a little bit. Okay, why don't you go fill out cosine of negative pi over 2, cosine of negative pi, cos of negative 3 pi over 2, cos of negative 2 pi. And pause me and then replay me. And the thing is, when I say that, I hope that you are all pausing me and replaying me. You could obviously not pause me and replay me, but then who are you shortchanging? You are shortchanging yourself. Cos of negative 90 is 0. Cosine of negative pi over 4, if you want to really be thorough, is boop, right there. All right, I'm going to go ahead through and take care of. Okay, so I hope with reasonable accuracy, what you're looking at here, and hopefully what you're noticing, is that y equals cosine of x is also a periodic or sinusoidal function. Some of you might say, shouldn't we call it cosinusoidal? And the answer is no. The word sinusoidal doesn't mean that the function here has to be sine. Sinusoidal, as you know, means periodic, cyclical, repeating, so on and so forth. I'm going to highlight a portion of y equals cosine of x. The part that I'm going to highlight is this one. And the reason why I'm highlighting this portion is because this shape is going to help us when we start looking at graphing transformations of y equals cosine of x. Okay? You may remember that sine x, y equals sine x, looks like this. You just had a test on this. I'm going to do it very quickly on here. You don't necessarily have to draw this part with me, but y equals sine x looks like this, everyone. Okay? And what I'm going to be talking about in class, right, when I see you is you know, I think it's not too much of a stretch to say that the graph of y equals sine x here in gray and the y equals cosine x are identical, except for the fact that one could argue that y equals cosine x is basically y equals sine x shifted a certain amount, and we'll talk about that when I see you in class. But for now, let's get back to the matter at hand, which is our new friend y equals cosine x. Okay, let me just go through and delete this. Take this out. Okay, now y equals cosine x, you'll notice that I highlighted one period of y equals cosine x. And you'll notice that the part that I highlighted, while it is one period, because after all, this is a pattern that is repeated, you'll notice that it's different than how we think of one period of sine, which looks like this. I'm tracing it in the air here, okay? It's nice for us to start with one period at x equals 0. And this is the kind of shape that we're going to shift when we start transforming it. So some body parts, these body parts should be familiar. There is an axis of the wave. The axis of the wave is the same as that of y equals sine x. It's still y equals 0. Okay, the amplitude is still the same. It's the distance between a high in the axis of the wave or a low in the axis of the wave. Okay, it's the distance between a max in the axis of the wave and the min in the axis of the wave. So no difference here. The amplitude does equal 1. Okay, that's no difference either. Also, what's not different is the fact that the period of y equals cosine x equals 2 pi radians. Or if we were in degree mode, it'd be 360 degrees. Okay? What's different in terms of how we're thinking about this is this issue, right, of one period. And if you kind of use the technique that I kind of showed you for graphing sine functions, I want you to look at this for a minute. I know the period of y equals cosine x is 2 pi. I'm going to cut that period in half, cut it in quarters, cut into 3/4. Sine, you'll recall, goes middle, top, middle, down, middle. Cosine goes top, middle, bottom, middle, top. Right? And then, of course, when we want to sketch more of the function, we will. Okay? Let's just do one example together here, and then that's it for homework tonight, and then tomorrow in class we're going to build from this. Go ahead and just find a new page, clean piece of paper, and I'm purposely, leaving this blank. And what I'd like for us to do is to try and graph the following. Okay, we're going to go ahead and graph. We're going to sketch, let's just say we're going to sketch 2 cycles of this. And you can see I'm going to jump ahead a little bit. Y equals 3 times the cosine of, let's do x minus 90 degrees minus 4. Okay, so just like before, we know we have a vertical shift down 4, and again this vertical shift will affect the axis of the wave. The amplitude equals 3. Okay, and then we're going to be shifting right 90 degrees. And the hint that I gave you is we do this last. We do the horizontal shift last. With a straight edge, let's come over here, put in an empty axis. Okay? Let's go ahead and put in the axis of the wave. Y equals -4. Y equals -4. Amplitude is 3, means we're going to top out at y equals -1. We're going to bottom out at y equals -7. Okay, let's see. I've taken care of the amplitude and the vertical shift. I'll deal with the horizontal shift last. There's been no period adjustment. I'm going to go on my axis of the wave here. I'm going to put down 2 pi. Maybe you can watch me do this first and then pause me and try it on your own. I'm going to put down 2 pi, cut it in half, cut it into quarters. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi. What does cosine look like? Cosine, unlike sine, it goes top, middle, bottom, middle, top. I'm dotting this. Okay, that's one period of cosine. Now I'm going to go right 90. Right 90 degrees. Oh, goodness, look what I did here. I'm either very impressed with myself or I must be very confused. I know I'm in degrees, but I labeled my axes in radians. But as long as I do it correctly, I'm okay. Okay, so I'm fine. Right 90 degrees means right pi over 2. So here's what I'm going to do here. I'm going to take my final finished product. This point goes right pi over 2. Right pi over 2. Right pi over 2. I'm up here. I need to know what this x value is. Use the denominator. 2 pi is the same thing as 4 pi over 2. That makes this 5 pi over 2. And then I have a cycle of cosine. But I ask for 2 cycles, right? I'm going to make this, let's see, 6 pi over 2 or 3 pi. I'll just add on. Let's see, I can go down like this. I can go, let's see, left pi over 2. I'm down here. And negative pi is here. And of course, I'm going to make sure the reader knows that I know this goes on forever in this fashion. Okay? So this is me sketching a transformation of cosine x. Tomorrow, what we're going to talk about is how do I rename a function in terms of cosine x, right, as a function in terms of sine x, which really kind of rests on the question, what is the relationship between the y equals cosine x and y equals sine x function? There's a relationship. I mean, it's kind of it's kind of too hard to ignore, right? I mean, we see here that it's too hard to ignore that there is in fact a, oh, where did it go? Well, okay, you have that big picture. All right, so with that, congratulations on the test today, and I will see you tomorrow in class. And I hope you've took good notes here. Okay, good night.